Hi there, I'm John from CNCKing.com, and today we're going to router out some polycarbonate. If this design looks a little bit familiar, it's because we did it with our laser last round. Again, we're just prototyping a product for a customer. And the nice thing about the laser for that, it was just a 1/4" MDF, which is fibrous board or just hardboard or whatever you want to call it. And all we need to do was double check the placing of these things so we could use the laser. Now the next step is to use the router to do it. And there's two reasons for that. Number one, production speed, and therefore the cost to the customer is dramatically lower. The other option that we can do with the router is, as you can see here, there's a bit of a bevel on this, or a chamfer. And that's something we could do with the router that we can't really do with the laser unless you do it by hand with a sander or what have you. This machine is a better machine to be doing those kind of projects when it comes to this. The other thing about polycarbonate is that it really likes to hold on to heat. Now, if I were to try to cut this with polycarbonate or with the laser, the polycarbonate would actually bubble up because it just holds on to the heat and then just starts to expand on you. So the first bit of this we did is the clear polycarbonate. The reason why it's not clear as you can see here, obviously, is because there's masking on the front and the back to protect the surface. It's amazing just how much plastic we process here in the shop. A lot of projects we do are under NDA and stuff like that we can't really show. Same thing with the stainless steel and the mild steel and the projects we do with our plasma. But it's amazing how much we actually process. In this case here, the first pass that we're doing here is actually with adding a chamfer all the way around on all the edges. The advantage to that is it's not a sharp corner. Polycarbonate can be incredibly sharp when it's just cut using a CNC router because you have a perfect 90 degrees and the polycarbonate itself is really, really hard. And with the vacuum system we have here, we're pulling it down. But when you take it off the table, you just gotta watch your hands. It's not as sharp as, you know, stainless steel edge, but it's pretty much up there. In this case here, we're just doing some prototyping on different ideas for the customer. So the finished product might look a little bit different than what you see here. Now what we're doing is multiple passes going all the way around with the router. And the reason for that is because the polycarbonate does not like to be router cut. And because of that, we have to take our time with it, otherwise it'll fly off the table. Now as you can see, I've been intervening in the production of it as it's happening, slowing down the machine, speeding it up, and all those kind of things. What I'm doing is trying to find the sweet spot. Polycarbonate is kind of a unique material because different shapes have different results. And what I mean by that is, if this was a lot smaller, I'd have to use tabs, for instance, to hold it in place, but it was large enough so that I could use the vacuum table. So I didn't need to use that. So basically when I turn the vacuum table off, this comes as a finished piece. Now because of that, I have to be very careful when I'm carving into it because I don't want to rip the sheet off of the machine because I got a vacuum sucking it down on the table. But I also have, as you can see here, there's a vacuum up there sucking all the debris up. So basically I have two vacuums, and in between that I have a bit that's spinning. One that's doing the chamfering, so it's not actually going through the material, but the other one is actually cutting through the material. So I have to, you know, sort of see where if I have too much of one vacuum, not enough of the other one, if I'm going too fast or going too slow, because remember, the bit is going through there and it's lifting up the material. And if I try to do it as just one pass, it will lift it right off the table, just because polycarbonate really does not like to be routered, and it likes to just sort of grab on. And that's why I'm turning it on and off and testing different things to produce, you know, a really nice finished result. I didn't appreciate the wonders of having a tool changer until I have one, and now I can't have enough tools on my tool changer. It's amazing how fast those things fill up. Now in this case here, we're using black polycarbonate, and again, black or clear, it makes no difference to the machine. The feeds and speeds are identical, so there's no changes in the production. And overall, the whole project here with the black polycarbonate is completely identical to the clear one that we did earlier. Now when it comes to cutting polycarbonate, you'll see there's some sort of lifting up all around the edges that you see here. And what that is not actually the polycarbonate. Polycarbonate cuts really fine, really clean. What that actually is the masking on the bottom and the top. And what that masking does is just a very, very thin film of plastic. So that has no really any strength or resiliency to it. So as soon as we pass over it with the router, it just lifts up, but it's not what you see on the final model. You can actually see some of it coming off along the edges there as well. Now the reason why we use the laser to cut this out is because it's 1/8 inch polycarbonate, and if we use our laser, it's just going to be a big mess because it holds onto the heat and starts to bubble up. Now in this case here, we also did a black polycarbonate. Now black or clear is actually a cheaper version of polycarbonate. It's more widely available. As soon as you go into sort of colors with custom plastics, the costs go up pretty quickly if it's non-standard, and that includes color. The material is 1/8 inch thick, so it's relatively thin. But even that being said, when I'm going through with the router, I'm actually doing 3 passes around it. So I'm chamfering the edges first. That's not going all the way through. Then what I'm doing is going through slowly, relatively speaking, going around and cutting it in 3 passes. Now, as you saw, I tried one with 1 pass and it actually lifted off the sheet. So 3 passes, again, I'm just being as gentle as I can with the machine and the product as a result. Because if I'm too aggressive with this, my machine can move 1200 inches a minute, no problem at all cutting basically anything. If I go through that with this here, you're gonna have a lot of issues, because what happens with polycarbonate is that as soon as it lifts a little bit, you can see some of these little chips. As soon as it lifts a little bit, these little chips just go right underneath you here. And as a result, you start losing vacuum relatively fast because you have sort of leaks happening everywhere. And that's why when I'm doing the last piece of the polycarbonate, I have to be very careful because I have a lot less vacuum than when I first cut it originally. So if you're looking for custom polycarbonate pieces, parts, or what have you, contact me at CNCKing.com. We'll make it for you and ship it right to your door.